Second part here is what? Let's see. Second part, that we need to find the total capacitance for these three problems. Okay, so let us see. Select all and delete. The first one here, you have this 12 and 4 are in parallel, in series. 12 and 4 are in series, and 3 and 6 are in parallel. So in this case, you can redraw the circuit, the circuit, yes, like this. This is 4 farad. Don't change it. And then you replace this 2 by 3 plus 6. 3 plus 6, which is 9. So you have 9 ohm. Okay. Why? Because they are in parallel. When they are in parallel, you apply the series rule. So they are 9. This 2. And then 12 and 4 will be 4 times 12 divided by 4 plus 12. So you can replace them by one capacitor. That is 4 times 12, because they are in series, 4 plus 12. Of course, 4 times 12 is 48 divided by 4 plus 12. I hardly can see the mouse here. That's what I don't like here. So it will be 3. This is 3. This is 3. Now, these two are in series, then you can just add them. Series, add 3 plus 9 is 12. And then finally, 12 and 4 will be series. So again, sorry, 9 and 3 are in parallel, then you can add them. And then 12 and 4 are in series, because you will look like this at the end. This is 4 and 12. It will be 4 times 12 over times 12 over 4 plus 12. We just calculated this one to be 3. So this is 3. This is the answer here for this example. For the second one, for the second circuit, here 4 and 4 parallel, then you add them, so it will be 8. So it will be 8. So you have 6 farad, and then you have 8 here. This is 5. So here you have 5 farad. This one is 6, and 4 and 4 will be 8. Then next, you have these two in series, then you multiply over summation. Sorry, this is 2, 4 and 2. 4 and 2 will be 6. So this is 6, not 8. 4 and 2 is 6. So here you have 2 in series, okay, and they are equal. Then you just divide by 2. 6 divided by 2 is 3. That's it. Or of course you can say 6 times 6 divided by 6 plus 6. So it will be 3. Then finally you have this 3 parallel with 5. 3 plus 5 is 8. 3 plus 5 is 8. They are in parallel. It will be 8. That's it. So this will be the second example. This will be the second example. Third one, we have 3 and 6 are in series. Then you multiply, divide by the summation, then you have 3 times 6 divided by 3 plus 6. 3 times 6 is 18, divided by 9 will be 2. So this 2 will give you 2 farad. 2 farad. And this 2 farad will be parallel with 4. When it is parallel with 4, you just add. So here it is. 2 and 4, you add them, so it will be 6. So here it is. Then finally, you have these 3 inductors, 3 capacitors in series. When you have 3 capacitors in series, okay, you have 2 ways here to do it. Because they are in series, then you have to apply the parallel rule. You can take them step by step, or you can just apply the general formula. For example, you can take this 3 and 6 together, they are in series. Then it is 3 times 6 divided by 3 plus 6, which is 2. And then you have 2 and 2. 2 and 2, they are equal. Then divide them by the number of capacitors will be 1. 2 divided by 2 will be 1. Or you can find the capacitance like this using the general formula like resistor. 1 over C. Because they are in series, you apply the parallel rule. 1 over 2 plus 1 over 6 plus 1 over 3 equal whatever. And then in this case, you can find C. Flip this number here, whatever you get here, and flip it. You can get it here. C. 1 over 2, 2, 1 over 2 here, plus 6, 1 over 6, plus 3, 1 over x equal 1. Okay, and then you flip it, it will be 1, of course. 1 will be 1. Same. Or, as I said, you can just take these 2 together. Okay, you multiply over the summation. And then you take this, the result with this one. Result with this one. You have only 2 also. So this is another solution. Let us look at the last example in this slide, which is this one here. Let's see. What does it say? See here that we have a current through inductor. We have an inductor. And we know the current, I. The current is 6 times e to the power of negative t over 2. This is the current, I. Okay, this is the current. We need to find the voltage, I believe. This is what we need to find the voltage. But yes, find the voltage and the power at t equals 3 seconds. Forget about this power at 3 seconds. We need to just calculate the voltage right now. We know that V for the inductor equal L di by dt. So this is the key, di by dt, or I dot. And L is given here by 10 millihenry. Then you can just say 10 millihenry. 10 times 10 to the power of negative 3. So this is L. This is L. And then you need to differentiate the current, this current with respect to time. The differentiation is not easy, it's not hard. You have this just 6 here. This is a constant. Time. The differentiation of the power here, which is negative 1/2. Because it is e to the power of negative t over 2. So it is, you just take the power, negative 1/2. E to the power of negative 1/2 t, or t over 2. So this will be the voltage. Then you can just say, for example, here, this is this one here, so this 6. You can take this 6 with 2, will be 3. Okay. Then you have a negative 3 times 10 will be negative 30. So you can say this is negative 30. And you can neglect this one now, the 10 to the power of negative 3. And you can say this is e to the power of negative t over 2. Okay? And because you have this 10 to the power of negative 3, you can say this is millivolt. Millivolt. So this will be the voltage across the inductor. Okay, this is the voltage across the inductor. If you want to find the power, what is the power? Power is I time V time I. V time I. The voltage is this one here. This is the voltage. And this is the current. That's it. This is the voltage. This is the current. You multiply them. And if they need the voltage and the power at t equals 3, all what you have to do is just substitute by t equals 3. Substitute by t equals 3. So, for example, V of 3 equal what? And I of 3 equal what? Okay. V of 3 equal negative 30 e to the power of negative 3 over 2. That's it. And I of 3 equals 6 e to the power of negative 3 over 2. You substitute by t equal 3 equal whatever here. Just calculate this. Get this number. I get this one. And remember this in millivolt. Milli 10 to the power of negative 3. Then when you calculate the power, milli time milli will be micro. Milli time milli will be micro. Okay, so you just, or you can just add this 10 to the power of negative 3 and make it volt and ampere. That's it. So this is the answer of the second, this problem here. So you see here, this is the current, V equal L di by dt, and L equal 6, here it is. L is what? What's L? Yeah, L is 10. L is 10. Okay, 10 milli. And then you have this 6 as constant. And then you take this average outside. Negative 1 over. It's supposed to be negative. Why it is positive here? Oh, this is the current. Okay. Oh, yeah. No, this is the voltage. Why it is not negative? I don't know. This is supposed to be negative. Supposed to be negative here. Okay, and that's why they have this negative sign. Okay. So, and then when you substitute by V by t equals 3, this is the answer. And then if you want to find the power, you substitute by t equals 3 for the current also, and then multiply the voltage in the current. So this will be the answer of this slide. Now, let us come to problems with DC, in case of DC. Remember that in case of DC, we know that the inductor is short circuit and the capacitor is open circuit. So this will make the problem very, very easy. Very, very easy. Not only very easy, but very, very easy. So the inductor, we have inductor, replace it by short circuit. Here it is, like this. This one is short circuit. And capacitor, just replace it by open circuit. So like this. That's it. Open it. That's it. And if you do that, you are done. Why? Because you don't have a capacitor or inductor. That's very simple. Like, for example, the first example here, you have inductor here, and you have capacitor. So you replace the inductor by short circuit. Here it is. And you replace the capacitor by open circuit. But what you notice here is that you don't have even the 5 ohm. Why? Because after you replace the capacitor by open circuit, this 5 ohm is not connected to anything. So it is worthless. It doesn't have any current. So you can remove it. So again, this inductor is just short circuit, and this capacitor is open circuit, and this 5 ohm will not be connected to anything, so it will not have any current. So you can remove it. So you end up with this circuit here. This circuit. Very simple circuit. And the voltage across the capacitor is the voltage between these 2 points here. since you don't have the resistor, it is the same voltage here. And the current in the inductor is the current in the short circuit. This is IL. So this is VC, and this is IL. Okay. VC, you don't have to solve it. So if the question here is to find VC, you don't have to solve it here. Why? Because if VC equal what? Equal the current times the resistance here. You don't have any resistance because it's short circuit. So in this case, IL, this current, times the resistance, which is 0, equals 0, of course. So VC is 0. VC is 0 without solving the problem. Okay, then all what you need to remember here is to find is IL. What is IL? To find IL, you can use current divider, or you can use nodal analysis if you want. You can use nodal analysis if you want. So let us see, for example, if you want to solve it using nodal analysis, that's fine. It's a simple problem anyway. This is 2, and this is 4. And here you have 6 ampere. This is 4 ohm, and this is 2. And then you have a node here. Let's say this is V1, and this is a ground. And you have one equation, one unknown, because you have only one node. The first current is -6. Second current is V1 over 4. So this current is V1 over 4. The third current will be V1 over 2. Remember that this is IL. IL is here. So IL actually is the last current, this one. So once you find V1, V1 over 2 will be IL. That's it. It's the same current. So equals 0. Then you need to solve this one. You can multiply it by 4 because this is a common multiplier. Then you can say, okay, 4 times 6 is 24, -24, plus V1 times 4, or 4 times V1 over 4 will be V1. And then 4 over 2 is 2, then this 2V1. And now it's very clear that this is 3 V1 equal what? Equal 24. 3 V1 equal 24. Then V1 equal what? Equal 24 divided by 3, which is 8 volt. So again, 3 V1 equal 24. Then V1 equal 8. Then in this case, you can substitute, find IL. What's IL? IL is V1 over 2, which is 8 divided by 2, that's 4 ampere. 4 ampere. So now we know IL and we know VC is 0. So finally, you just need to calculate WC and WL. The relations are here, 1/2 C VC, 1/2, sorry, C VC square. This one is 0. And this one is 1/2 L IL square. IL square equal. So let's see. C, even if VC is not 0, you need to remember what C. Sometimes I ask this question, what C? Somebody did not know. C is a 2 farad. This one. This is C. So C is 2 farad. 2 farad. And VC is 0. There's this. Okay, so this is C is 2 farad and VC is 0. L is 0.5, 0.5 Henry. So this L is 0.5 Henry. Henry. And IL, we just got it, is 4 ampere. 4 ampere. This is IL. It will be 1/2 time 1/2 0.5 time 4 square equal whatever. So it will be 0.5 1/2 time 0.5 time 4 square, which is 16, equal 40 watts. So this will be 40 watts. 40 watts. Okay, so this is the answer of this problem.